Okay, I think we're starting. Welcome to the Reactive Programming Patterns with Java 8. Just wanted to say that I am really excited that Java 8 is adding lambdas. How many of you guys are excited? Sweet, sweet. I think that's everybody. All right, so who am I? In case you want to know, I'm a Scala guy. I'll be honest. I admit it. Okay, so I'm also a huge nerd, and I just love doing functional programming, so it's really exciting to see it start to take more and more, hype and actually people using it. So, I work for Typesafe. All right, the goal of this talk is we're going to take two different systems, grab data from them, and render them into one page, and we want to do so as efficiently as possible. So one thing that reactive programming is really good at is when we have these asynchronous calls to other things happening, we can create these flows of how data comes into our system and flows out in a completely asynchronous way. Java is going to give us that in Java 8. So first we're going to talk about what it actually means to be asynchronous or reactive. We're going to talk a little bit about new Java 8 futures, which is going to be probably recapped for a lot of people here. I'm sure you went to a lot better talks for that. And then we're going to talk about some basic patterns. And finally, we're going to talk a little bit about play. One of the reasons I'm really excited is because a lot of the things we do in play and the Scala API, you'll finally be able to do in a very elegant fashion in Java. So a lot of the concepts and things I'm showing you are actual design patterns that have emerged in Scala for doing reactive programming in play that will now be more and more viable in Java. Okay, I also want to mention there's a reactive manifesto out there that a lot of people are getting behind. It defines the tenets behind what reactive programming is. Reactive is this idea that we start with an event-driven model, and we use an event-driven model to design resiliency and scalability, which we'll talk about more in this talk of how you can gain that. And through doing so, we end up with a very responsive, very user-friendly application. So, what does it mean? Asynchronous. This is a fun term. I would bet that if we use the actual definition of asynchronous, everybody here programs asynchronously. Asynchronous programming, according to Wikipedia, means that a specific operation begins after the receipt of a signal. All right? How many people have used sockets? Okay, awesome. If you use anything on top of sockets, you're programming asynchronously because you get a request from somebody and you perform something when it's done. That's all asynchronous means. That's it. It doesn't actually convey enough meaning for what people normally say when they say asynchronous. You can be asynchronous and you can block, right? Servlets block. When I have a servlet thread and I need to make a database query, I call the database method and get my results back. And there's actually a separate thread that's created to listen to that result. And it sends information back to me. I'm kind of passing things between threads, and I'm blocking everything for the servlet on a particular thread, but I'm still passing data around, and that's not really good for CPU cache. But it's still asynchronous, okay? It's still asynchronous. When you hear a lot of asynchronous hype, what people are really talking about is if you can not block when you do this, we might not actually have to pass this data back to the servlet thread. We might be able to keep this data on the thread where the database query came back, and not have to take a cache hit, or a cache miss, I should say, a performance hit from a cache miss. So the tenets for good reactive programming is basically we want to avoid blocking threads so that something can optimize our use of the CPU. If we can avoid changing threads, that actually optimizes the use of the CPU cache. And we want to be able to avoid crippling failures. So if something fails on a particular thread, right, and it takes that thread down, that should not kill the rest of the system or the rest of the workflow. So tying things to a particular thread is a little dangerous here because threads can disappear. We need something outside of them. Luckily, in JDK 7, the fork join pool was added, and this has enabled the whole reactive movement on the JDK. This is actually the driver behind the Play Web framework. It's the driver behind the akka actor system. It's what gives us our performance, and it's our magic secret sauce. And it's been available since JDK 7, but not necessarily in a very easily consumable form. So, fork join pool helps us avoid cache corruption. We'll show that. It understands that some tasks have to wait for others. It's optimized for tasks that create new tasks that need to run. And it can avoid changing threads until the workload is significant. We have this interesting dichotomy at play here for performance. For performance, you kind of want everything to be on the same thread to avoid cache misses in a small. But for scalability, and when we have 8 cores, we want to fragment out the work so we're using all of them at the same time. The fork join pool helps us unify those two ideas for an optimal system. So, the key assumption in the fork join pool is that newly created tasks are more likely to have their data in a closer cache to the CPU than older tasks. So let's look at that. If I have a fork join pool, I have a set of threads. Each thread has its own queue. When I tell the fork join pool to do something, that task goes into a queue for a particular thread. Okay? Then it gets run. The fork join pool, every thread will pull from the top of its own queue. If the task creates new tasks, right, inside of a particular thread, they go directly on his queue. Unlike, a generic thread pool, it doesn't just go to spam one random thread, it goes to its own pool. And then, when the fork join pool needs to run another task, it grabs right off the top, because most likely, since it was doing task 1 and task 1 created task 2 is probably close in cache, and it will be relatively efficient to run that on this thread. Okay? Now, what happens if this other thread is empty and needs work to do? He's going to steal from the first queue. He's going to take from the bottom. The idea being, when I pass tasks across threads, it better be worth it. Okay? It better pay off. The amount of time it takes to send this from one thread to another and synchronize and all that crap should be worth the amount of tasks that I'm doing. So that's why we grab from the bottom and we grab some, and then we start running. Because we assume the ones at the bottom are further away from cache. So, if we use fork join for asynchronous, we get the ability to split up our tasks very well, and the fork join pool will try to keep them on the same thread for performance, and we'll send them to other threads when we have enough to start parallelizing, and it will try to keep it as performant as possible. So in the past, this wasn't necessarily a great idea to fragment down into these really small tasks and pass them between threads, but given this kind of a scheduling, this kind of an optimization, the performance is actually pretty darn good. So in Java 8, we now have a completable future, which is different than Java's future. What completable future allows us to do is to start chaining these small tasks. We can take a method that has a whole set of things to do, we can fragment out the method into chunks, and we can pass it through the future. Okay? So the 3 things that I'd say you have in completable future that matter are chaining. After this work is done, go do something else. Maybe on this thread, maybe not. Joining. When these 2 tasks are done, run this effort, or run this next task, and I need both of them to be done first. And then failure recovery. Failure recovery is a way externally from a thread to say, if an exception happens here, right, recover over here, and here's a default value for it. So let's look at completable future a little bit, okay? This is an imaginary play framework built on Java 8, which I hope will exist in 3 months, but we'll see. Anyway, so the way this works is we get in a request, like a HTTP request, and we're going to construct a completable future of a web result. That's what we're doing. Okay? So first, we call a method called latest blogs. Latest blogs is a mechanism to go ask our blogging system, okay, about the data, and it comes back in a completable future, and it gives us a list of blogs. Then we go get our user information from our cache of user information, because we want that available really, really efficiently. So current user data is going to try to hit the cache, and if it can, it'll go down further. After that, we combine our blogs and our user using the method render homepage. So it's going to take user and blogs, create a set of HTML, and it will return that in a completable future. And finally, we return a result of this asynchronous call. So the Play Web framework actually, is 100% asynchronous, so this is how it's going to look. Grab latest blogs, grab the current user, wait for both the blogs and the user, render the home page, and then tell the web framework to render. Okay? So let's look at the new features that were in there that I'm glossing over. CompletableFuture is the most important one. It's kind of like Java util concurrent future, but way better. You can chain asynchronous operations. We're also using method handles, which are a way to directly reference methods. And this is a way you can keep your code clean and explicitly denote the decisions or the partitions of your logic in your asynchronous flow. You can actually create a method and then lift it into a handle to pass it to the completable future. This is what a method reference looks like. Okay? It has this little colon thing. But before we really look into that, you kind of need to know what then combine async is, right? We're calling blogs.then combine async. And I'm doing the mean speaker thing of showing you like the whole API without explaining anything of what it does. So let's look into that. Here's the definition of then combine async. Yeah. Makes sense, right? Okay, this is something we learned in Scala. A lot of these generic functional type programming things really using U and V and T doesn't really help people understand what the hell is going on. So what we're going to do is we're going to rename this, hopefully with a little bit better names for you to understand what this API actually means. The first thing we're going to do is remove variants. If you look at question mark extends, question mark super, how many of you guys have used that in Java? Okay, great. You'll have to use it a lot more when you do FP. You're going to have to use it everywhere you use a function, unfortunately. And it will look exactly like this, of question mark super T for things that you're taking in, and question mark extends V for things you're sending out, unfortunately. And that's just how it is. So we're just going to have to deal with that, but let's ignore it, because it doesn't matter. All right, so what we have now is we have a by function of TUV. Well, that makes a lot of sense, right? Let's improve it, all right? We have a result. This method is going to return a completable future that contains a result. Good. There's something at the end of it, a result. We have the data that's inside of our current future. Okay, completable future dot then combine async. There is data inside of the current completable future. That's what this type variable is. And then we take other data. Now, I will admit that data and other data aren't that much better than T and U. Okay, I know. But I'm trying. It's kind of hard. Anyway, all right. So my jokes are, on myself as well. Anyway, what we're taking here is we're taking another completable future called completion stage, which is an abstract thing above completable future. It has the same API. It's an interface. So we take in another completable future of some other data. We take a by function. A by function takes in two inputs and produces an output. So this is a function that takes in data, other data, and returns result, and we get back result. So what we're doing is we're taking two completable futures, running the function that we get when both results are done, and we get a new completable future with the result of this by function. By function is an interface that takes in two things and returns something. And again, it has some awesome, things here, yeah? I love my brackets, okay? And in action, when you have a by function in Java 8, you can, instead of, say new by function and then implement the interface, you can use a lambda. How many of you guys, do we not need to cover this at all? Anyone want to cover this stuff? Okay, I'm sure you've already seen this, so we'll skip a little bit. There's the lambda, the by function, the arguments, the body, yay. A method reference is basically a way that we can take a method that has the same signature as the function we're implementing in the interface and just lift it right up into that interface. It'll construct, an instance of the interface that just calls the method. Okay? So this is calling combine on string utils. Great. That's the object or the this or whatever we want to call, and then colon, colon, and then the method. All right? So back here, render homepage is our method that we want to lift into our asynchronous flow. All right, so back onto patterns. This is kind of how we think of reactive programming. This is how you want to think. You want to think as a data flow, workflow, okay? I'm going to get a request for the user profile. Based on that, I'm going to perform these 4 actions. I want to get the user profile data from storage. I want to grab any recent tracking data information I have from the live index. I want to get advertisements that I'm going to display on this page. And I'm going to update my click log. Okay? When the first 2 are done, I'm going to render the accounts, et cetera, et cetera. All right? It's a flow. There's a fan out, a fan in, fan out, whatever. Okay? This is how we think now. Instead of directly saying in one method to do all these things, what we do is we split each one up into different methods. So asynchronous sequencing is where we say do something, then do something else. Well, to do that on CompletableFuture, there are, 4 methods. There's then except, and there's then apply. Then except means I'm going to run a function after the CompletableFuture is done, sometime in the future. Okay? Then except async means that I'm going to let the fork join pull figure out when that happens. I'm going to let the CompletableFuture figure out when that happens. If I just use then except, I'm going to block my current thread until the whole chain is done, and then I'm going to run this function. So you should prefer to always use the async variants on this API, if you can. Because once you block a particular thread, you've given up the ability to let the fork join pull optimize how your code fans out, how things execute, when things pass threads. You've completely given that up and you've taken it over. There are times where you will need to do that, so those APIs exist, but definitely always, always, always prefer the async method over the non-async one. Okay. So then apply is one where given a CompletableFuture, you can pass in a method or a function that will transform the value to something else and then give you another future with this new thing. So, pattern number 2 is the asynchronous join. We have 2 different things. We want to put them together, and then we want to perform some action after this last thing. So we want a new CompletableFuture that tells us when the first 2 are done and executes some extra behavior. So there's then combine, async, which I showed before, that takes, given one CompletableFuture, it takes another one. When they're both done, it will run a method. Great. There's also then except, which will run a function that doesn't return anything. So this is a way to do a terminal use case in the flow, right? If we look back at the flow, we had a few terminal use cases. Update the click log. That's when you use these then excepts, okay? Okay. All right. Sorry, for some reason this is getting quite slow. Okay, next up is the use case of recovering from failures. So the way we recover from failures is actually CompletableFuture is going to fire 2 different events. Right now we've been calling methods that actually do something if the event it fires happens to be success. If the event happens to be failure, what happens by default for those methods is the failure just goes into the next CompletableFuture, and you can inspect that one, and it'll tell you there was a failure somewhere in the chain. You don't know where in the chain, but you do know what failure it is. You know what the exception was. Okay? So what we can do to handle failure in the chain at any point is we can actually directly respond to a failure event sometime in our past. So here, we're actually designing something where we take the result of pulling the user profile from our cache. If there was a failure pulling it from the cache, we're actually going to go execute a stage that pulls the user profile from storage, and then we join these 2 things together to say, whichever one succeeds first, I'm going to take the value. It's a recovery. The way recovery works is there's this exceptionally thing on Completable-Future, where I can say, give it a function that takes the exception that was thrown and returns a value to use instead by default. So if there was an error in the previous pipeline, I can create my entire pipeline and say, exceptionally, here's a default value, and I'm guaranteed that if any error happens, I'll get a default value and still have a valid response. So this is kind of how we do error handling, regardless of what thread is throwing the message. Right? We're moving the error handling, the recovery outside of the actual stack. So a quick recap, we're using Completable-Future. We use then and combine without supplying an executor. In all of the example code and the things I've showed you, there's actually alternative ways to call these things that includes passing a specific executor into the Completable-Future. If you do that, you don't give the fork join pool a chance to optimize. Again, because it thinks it needs to send it to a different thread pool. So it's actually going to be an external thing. So you don't want to do that. And you want to recover from failure by providing good states, and you can use play to learn reactive now. So what I want to show you real quick, is I want to show a little bit of the reactive stocks application that we put out from Typesafe. This is an example reactive application. There's pieces in Scala and there's pieces in Java. The piece that I want to show you actually happens to be in Scala, just because, but it's going to show you kind of the same thing we're going to see in Java 8. And that is that we are creating methods which are the asynchronous stages in our pipeline, and then we're going to flow those together using futures as a separate thing. So here is the actual play call. This is the get controller method, okay? And we're going to perform an asynchronous action, and this is going to return some sort of a result when it's done. So in Scala, instead of chaining things using then async, then accept, that sort of thing, you're going to see this. Just ignore it. We're Java guys. We're going to use, then accept, then async. So in this, we call get tweets, which is a method which returns a future. Okay? And then we're going to after we return that future, we're going to call then combine with load sentiments from tweets. Okay? There's this sequencing thing, which what this is I'm actually given, what this application actually does is it checks tweet sentiments. So we go grab a set of tweets about a particular stock symbol. For every tweet, we go issue an API call asynchronously to grab the sentiment of that tweet from our tweet sentiment service. Once the sentiment values come back, we join them back all together and execute it. The code in the Java 8 API is going to be a little bit more, there isn't actually a sequence method, so I'm kind of glossing over that. But you can see, in general, we have these methods we call, which are asynchronous. We join them together using the futures library. If we look at those methods, get tweet sentiment, it uses the web service API of play, grabs our sentiment URL out of our configuration, posts some text, and then gets the result as a future response. When we get those responses, we want to actually average the sentiment. So we have this get average sentiment guy that is taking in just raw responses, not wrapped in futures, right? Just raw ones and returning a double. So you don't actually see future here. You only see future show up in your methods when you are asynchronous. So in your Java code, when you're writing in this reactive style, you want to try to avoid actually having your raw methods have future in them. Does anyone know why? Any guesses? You'll need to block to call it, yes. And it makes testing a little bit more difficult when you're actually doing things asynchronously. So if you can keep your raw methods like, logical functions and run tests against them, it is really, really, really nice. Because you have these small testable fragments of code, and then you're chaining these things together, and you can be reasonably assured that if the small components work, the large one does, and then you can save the integration test for your integration as opposed to in your unit tests. So you should always have integration tests, by the way. I don't know if anyone doesn't, but I've learned to rely on those more than unit tests myself. All right. Anyway, you can see these methods. There are some that return futures, and as many as possible do not. As many as possible are on raw things, specifically for testing. And then we use Scala's syntax sugar using for to lift these and yield the result. And you can also see this recover with, which is the last method we have. If we get a no such element exception, which is the error that happens if the JSON is invalid, I don't know why, then we're going to return a JSON object of, hey, there was an error to the UI. All right, we're always returning JSON to the UI in this reactive call. So again, we have this flow here. It happens to be in futures. I'm going to go back to the Java in a second so you can see again the Java style. You do your flow, you fork and join, and then you recover from failure at the end. Okay? All right, and if we look at the Java code here, this is actually a WebSocket application. Man, I think my CPU is burning a hole right now from something. I think it's trying to update over our internet. So I'm just going to go back to the Java. Yeah. So if you look here, we're gonna recap after we saw the actual play web framework in Scala. Okay. We start with calling latest blogs. Latest blogs is returning that Completable-Future list of blogs. Why? Because latest blogs is hitting a web service. We call current user data, and current user data is also going to return a Completable-Future. Why? Because it's calling a web service. So we get back that future. However, when we render the home page, that is something we could actually test. That is a method that just takes in the user data and the list of blogs and returns HTML, and if we wanted to write tests directly against it, we could. Practically, I don't know if you guys do that or not, but you can. So that's why we just call the method directly there. What should be in here, but I totally forgot to, was the recover with. Sorry. You should have a recover with method after you combine these things to return HTML in the event of an error on either of the two possible values. What play will actually do for you, if you're using play with the current future API, is it will return a error page for you if the completable future fails. So it depends on what, if you like the default play 403 or whatever, that's what you'll get. So, okay. Did we get to, here we go. Back up and working. I think. Here's application.java. Another thing that gets really interesting here is when you start talking WebSockets. Okay? So with play, WebSockets now become a thing where you're taking things in and sending things out all the time. So how does that really fit into Completable-Future? Well, it doesn't. Right? It doesn't. Completable-Future is a great way of taking disparate systems with asynchronous calls and joining them together. However, it is one mechanism of many different types of ways of doing reactive programming, and it is not the only mechanism. Okay? So with WebSockets in here, we're using Java with akka, and when you call or open a WebSocket, you get this, we create a new WebSocket that gets an in channel and an out channel where we can send in and out messages. And this is a very message passing friendly thing. So futures are a very data flow diagram thing. It's not necessarily direct message passing where I have in and out state. When you're doing something like that, you really want to use actors. That's exactly what they are. They are message passing frameworks. Or you want to possibly use something else that is message based. Okay? Futures are not going to be your best friend there. However, you can use akka. You can use it with Java to create actors, to send in messages, to get responses, and that's going to work better with WebSockets. However, I'm not going to go into actors because this is mostly the future API. That said, I actually talked really fast. That's the the end of the demos. I'm curious, I wanted to give some time for question and answer about Reactive. Since, for the most part, Java 8 isn't actually out, and a lot of the frameworks and stuff, the only actual example right now is the Future API in play. So I'd love to hear questions based on the stuff that we've learned. And here's kind of the speculation of what things will be like in Java 8. And I'm trying to give you guys examples from what we've learned in play that will apply, hopefully, across all frameworks as we move asynchronous. So yeah, any questions? Yes. Behind you, there was the first hand, yeah. So the question is, can the exceptionally value itself be a new flow? The answer to that is not with the exceptionally call. There's actually a different method you have to call where you can do that. It's a compose call. I think I cover now. Yeah. So if you grab the API, there's basically two different methods. There's then accept and like exceptionally, and then there's I actually forget the name of the method. There's compose that will allow you to return with another completable future, and you can actually do that to join together two completable futures and flatten them out. So what you do is you essentially add that chain as an exceptionally to respond to it. That's one possibility, or use this other method. And then you use this compose to flatten the futures so that when the internal future is done, the external future is done. That's when things start to get really complicated. That's when you start to hear words like monad, and that's when you start to get scared. But that's definitely, that's exactly what that is. It's the first thing you want to do when you start working with functional programming. And it's there. It's called compose, but it's a little complicated. There's a lot of machinery in Java to kind of get that working. But it's definitely possible, and I totally recommend it. In Scala, the way that works is that for expression you saw. We're actually, yeah. Inside of this recover with, we're returning, you see a future. So in Scala, these kind of like, deconstructing things of, the flattening operation of like returning a future inside of this method and flattening the futures is kind of like baked in. In Java, there's a little bit more, in the Java 8 API currently, there's a little more mechanics you have to do, but it's still possible. So, yeah. Any other questions? There were a bunch. Right here?
I don't understand exactly how can I use this asynchronous way of thinking with the transaction concept. So how can I roll back everything, for example? How can I have atomic operations?
So the question is, how do you have atomic operations given everything being asynchronous? So this is where things get kind of interesting, right? You can actually pass the transaction that you're operating in down across the threads, and when you hit an abort feature, you can roll back to the start of the flow again if you wanted to, by basically saying, on failure, go start the method again, okay? You can literally do that. The difference, though, a lot of Java APIs right now are tying the connection, transaction, and session directly onto a thread via thread local. That it needs to go away. Right? In play, they actually did a lot of work to kind of rip this out and kind of chain it through other mechanisms. In Scala, we use implicits for that. With Java, essentially, you're going to see a different way of threading context. It could still be on a thread local. You'll just see a lot more thread local kind of update changes. But yeah, you have to thread the transaction through the flow so that you can do this. So, having a context with that kind of stuff in and passing it across is going to be more important. Yeah. That's actually what we do for Activator. Any other questions? Right back here? This is, yeah. Yeah, so there's an RX Java library. The question is, what opportunities are there for doing this reactive style in previous versions of Java? So right now, you can use Play, which is a great opportunity. The RX framework from Netflix is awesome. It's slightly different, but you essentially are thinking in the same workflow pattern. You're doing so using streams and observables, and it's definitely a great mechanism if you're on an older version of Java. Again, I think as Java 8 comes out, we're going to see more people standardize this, and there'll be a big push to move to it, because there's a significant reason for us to pull the ecosystem onto lambdas. There's so much goodness in Java 8. I think it's going to be one of those big pushes the way Java 5 versus Java 4, where a whole bunch of people wanted to use generics, and then you had this division in the ecosystem for a while, and you kind of hated everyone who wasn't moving, but you were stuck yourself, that kind of thing. We're going to see that again. So if you're stuck, Play, Akka, Akka actually has a future API in there that will work similar to this. You'll have to use the anonymous class method. The Netflix Reactive is great because you're using observables, so it's a little more natural in Java, the way that you're doing things. It's going to feel a little comfortable compared to trying to do functional programming in Java. My preference, I went to Scala to do functional programming until Java had lambdas, so that's another option. But that's definitely not for everyone. Yeah, RX Java is a great one. Any other questions? Yes. How do you specify timeouts and test for timeouts? Testing for timeouts is actually a pain. I'll just be honest. We do have tests for timeouts where we'll do something and then wait for a timeout, but you don't want to run that on a daily basis. You want that as part of your integration test suite as opposed to your unit test suite, because that it's guaranteed to take X amount of time and be annoying. In that case, I recommend having your integration test for that. But in general, as a developer, I just kind of trust that if there's a timeout, things are going to work. That could be bad, but I do trust that the implementers of the ComplettableFuture will have implemented that method correctly, the timeout method. On all of these, when you listen to results, you can set a timeout for how long you're going to wait before you return. In Play and Akka's future API, you explicitly have to make an await call. So it's better if you actually never wait. That can be good, but when you're doing any of these, you definitely want a timeout at the end as well as handling failure, because that's a valid possible issue. So yeah. Anyway, there are mechanisms to do timeouts. There are mechanisms to actually mark the future as done with an exception on timeout. So you can actually run a future that will complete as a failure with a timeout and sync that in your chain using then combine async. And what happens is if the chain on the left-hand side doesn't complete before this one has an error, the result of the whole thing is an error, and it completes immediately and sends the error back to the user. So that's your mechanism of doing timeouts in the Java 8 API, and it's not bad. You make one method that does that, you test that, and hopefully everybody uses it, but it's still, testing timeouts is a pain. I haven't seen a good mechanism of that, of doing it. So, any other question? All right, well, we're going to end it. Oh, here we go. The async method at the end, where is it? Oh, that's a Play thing. So Play requires you to return a result. This is Play 2.1, not 2.2. So in Play 2.2, everything returns a future of something, or a future result. In Play 2.1, you always return a result, and you would actually lift an asynchronous result into a result via the async method. That's all. So this is the vision of what Play is going to look like in Java 8. But again, not quite there yet. So, yeah. Any other questions? Way in the back. So can you repeat it? Oh, so you're saying there's a library that does this in Java 6 and 7? Okay. Yeah, I actually, I was unfamiliar with that. So apparently there's a library that also does this kind of thing in Java 6 and 7, which you should take a look at. I really hope that that library also uses the fork join API, because that's what actually gives you efficiency. If it wasn't for that library, trying to make these other APIs would not be possible. But yeah, there's a backport of fork join for Java 6 that you can make use of. If you find a library that does this in Java 6, you can use Play, you can use Akka. There's the Netflix Java, RX Java. They're very efficient. So I totally recommend playing around with this now and get a feel for it. It's not going to be as elegant as it can be in Java 8. This code is far more clean than the same code that we have in our examples for Java. So I'm really excited for Java 8. Any other questions? Okay, thanks guys.